Welcome to a lesson with Dr. Powell. Let's give some motivation for the idea of average value of a function. First, let's think about the average value of four numbers, 1, 1, 2, and 3. We can add them up, divide by 4, and we get 7/4. Now let's think about this 7/4 for a minute. If we were to have a rectangle with height 7/4 and then multiply that by 4, notice that we would get an area of 7. Well, an area 7 is precisely the area that we would have here if we were thinking about each unit box here being just 1 high. So here this would be 2 high, 3 high, and then 1 over, 1 over, 1 over, 1 over. So we can think of this as being 7 as being the total area. And so kind of what we're doing is we're trying to make a rectangle that has the same area as these bars that we see here, the 1 bar, the 1, the 2, the 3, all put together. Can we make it into just one simple rectangle? And then we're looking for the height of that rectangle. So averaging is kind of rectangularizing an area. You make the area, you try to take this area and you make it into just a simple rectangle with a single height. That single height is what averages everything out. So we can apply the same idea to functions. Namely, if we have a function and we want to find the average y value of the function, we kind of think about the average visually as being something, a height, such that the rectangle up to that height over that interval has the same area as the area under the curve. How do we find that average height? Well, let's think about it. A rectangle has area height times base. So height times base, b minus a, that would be the length of the base there. That would be equal to the area, which is simply, we can get by the integral itself. All right. Now h, remember that's the average. That's the height of the rectangle. So if we just divided both sides by b minus a, we'd get the average. Hence, we have this idea: find the area, divide by the width to get the height. And there we have it. Thanks for watching.